Alright, AP, let's try this. Yeah, I filmed this and it got corrupted. No idea what happened, but it was very frustrating. So here we go. Pause the video. Okay, you'll be writing this in, the table in. Okay, draw your coordinate plane here, but only the black graph for now. Okay, the red graph ignore. So only the black graph. Okay, and then of course I will explain how to get the red graph. Okay, so the most confusing thing here is interpreting the graphs as areas, and you'll see what I mean as we go through the video lesson. I think that's the hardest part to grasp here, going from how we're used to interpreting graphs as y values, but starting with something that we interpreted as area, an accumulation of area. So in this video, that's what we're going to wrap up. We started it at the end of Wednesday, right? So make sure you go back, review your notes, or review the video. It's posted, okay? So that we can have that foundational idea of what an accumulation function is, okay? So where do these values on the table come from? So again, we're looking at the black graph right now. Ignore the red one. For the black graph, okay, at x is equal to 0, there is no area, right? You're still just on the origin, so 0. F of x, okay, represents the integral. This is the graph of the integral, the accumulation of area. Okay, at x is equal to 1, okay, you have this little triangle here, a base of 1, a height of 1, right? The area of a triangle is 1/2 times the base times the height. Okay, so that's all it is. Okay, and when you find that area, you get 0.5. Okay, at x is equal to 2, you can either look at it as this entire triangle here, or you can look at it as the 0.5 area for this little small triangle plus the area of this trapezoid that's right here. This area of the trapezoid, right, has a height of 1, a base of 1, and a second base of 2. So 2 plus 1 is 3, times the height 3, divided by 2, 1.5. So now that's 0.5 plus 1.5, and you get 2. Okay, so that's what's happening with these values here. These represent the accumulation of area. Okay, at x is equal to 3, again, you can look at it as this entire triangle here and find the area there. Or, now you know this little triangle plus this first trapezoid, that was 2. So then, if you find the area of this trapezoid right here, okay, height of 1, base of 2, base of 3, so 3 plus 2, that's 5, times 1, that's 5, divided by 2, that's 2.5. So this trapezoid here is 2.5. 2.5 plus these areas here that added up to 2, you get 4.5. So at x is equal to 3, that's 4.5. Okay? And what's happening is, okay, as you move along the areas here, right, either calculating by trapezoid or calculating by triangle, okay, you'll see the accumulation of area increase, right? At x is equal to 4 now, okay, that's this triangle, the area is 8, okay? From 0 to 6, all the way here, the area was 12, okay? And notice this is above the x-axis, so that means this is positive area. As we reviewed last time, right, any area under the x-axis is negative. So then, that's why you'll see, starting with x is equal to 7, which is right here, the accumulation area starts to go down. Okay, this little triangle here is similar to this first one. Okay, a base of 1, a height of 1, so plug into the triangle formula, you get 0.5. So this entire triangle here, all the way from 0 to 6, was 12, but then when you subtract this 0.5 area of this little triangle, now we're at 11.5. Okay, and same idea, now you have this trapezoid right here, right, a height of 1, a base of 1, a base of 3. When you find that area, okay, you get 2.5. okay, so 2.5 plus 0.5, that's 3. So then now from 12 you went all the way down to 9. Okay, and you keep going. Notice I skipped 9. Okay, it doesn't really make a difference though. When you go all the way to 10 though, when you find the area of this triangle here, okay, you find the area of this triangle to be 6. Okay, and it's 6, right? The area of this triangle here was 12, so 12 minus 6, right, you get to 6. So the accumulation of the area from 0 to 10, okay, is 6. Now, where does this red graph come from then? Okay, now that you have a table of x values and the accumulation of the areas, that's what you're plotting now here. Okay, you have 0, 0 right here, 1 comma 0.5 there, 3 comma 4.5 right there, okay, 4 comma 8 right there, 5 comma 11, 6 comma 12, notice that's the highest point of this graph, okay, 6 comma 12, and right, starting at x is equal to 7 right here, that's when the area started decreasing, right? Whoops, 7's right here, 11.5. 8 is 9, and then 10 is 6. Okay, so a couple of observations we need to make. Okay, knowing this graph here, right, that represents the area. Notice that the graph of f, okay, the graph of f increases, okay, increases as long as the area keeps increasing. Okay, don't look at it as right here increasing and then decreasing. No, remember, this is an area function. So as you went from 0 to 4, but then 0 to 5, the area was still increasing. 0 to 6, the area again was still increasing. So from 0 to 6, the graph increased. Okay, so again, that's probably the hardest conceptual part students have or get mixed up with here. Okay, if the area keeps increasing, in other words, if it's above the x-axis, the graph of f will keep increasing. Okay, then the graph goes under the x-axis. This is negative area. So starting from x is equal to 6, you can see that it started to decrease because the total area, right, started to decrease. Okay, so above the x-axis, graph will increase. Below the x-axis, graph will decrease. Notice right here where it shifts from positive to negative. Okay, that's the critical x value. Okay, and notice that gives me then the absolute extrema. That would be the absolute max. Okay, and then in addition to that, you'll notice that let me see, we have a couple of inflection points, right? Here it's concave up, switches to concave down. So at this point here, if we go back to the area function, that would be the max of the area, right, on this graph. That's going to interpret as the inflection point for f. Okay, and similarly, the minimum, okay, right here becomes the inflection point for f. That's where it's going to shift from concave down to concave up. Okay, so that's how the graphs are related. Let me see here, am I missing anything? No, yeah, so critical point, absolute extrema, okay, the max of the area, the minimum of the area here of the graph, those are the inflection points. Okay, and yeah, where it's above the x-axis, graph will increase. Where it's below the x-axis, graph will start to decrease. Okay? Alright, so yeah, so then now we move forward to this is 6.3 Form A. So here's the graph that they gave us. Okay, so make sure you draw it in. And this property here was one given. Okay, and I'll explain this property in a bit once we get to the appropriate question. Okay, but write in the property. Okay, this is a problem. Geez. Let f of x equal the integral from 0 to x. Okay, from 0 to x. So starting point 0 to x. Okay, and we're observing this entire graph from -5 to 4. First question asks us to identify the critical numbers. Okay, so just like from the previous graph, that's going to be where the graph is on the x-axis. So that's at -2 and at 2. Okay, so wherever the graph is on the x-axis, those are your critical x values. So I will go ahead and answer number 1 for the other forms, form B, C, and D. Okay, if you look at form, where is it? Here it is. For form B, you'll notice that the graph is at -3 and at 2 on the x-axis, so those are the critical numbers. Okay, for form C, the graph is on the x-axis for -2 and 2, so those are the critical numbers there. Okay, and then for form D, the graph is on the x-axis for -2 and 3. Okay, so those are the critical numbers for form D. Okay, so I just answered number 1 for all 4 forms there. Okay, question 2 tells you or asks you, determine the intervals where f of x is increasing. Justify your answer. So going back to this one, right? Where is f of x going to be increasing? Well, if you're above the x-axis, area keeps increasing, right, as you go from left to right on the x values, so then the graph will be increasing. Okay, if you're under the x-axis, that's where the graph will start to decrease. Same thing applies here. Okay, sorry guys, let me mute the volume there. Okay, same thing will apply there. Okay, and here we are. It says justify, so I did a quick little analysis here. Okay, here's f, right? If f is under the x-axis, okay, from -5 to -2, okay, f is negative, the area is negative, okay, so then f will be decreasing. Okay, from -2 to 2, that's the semicircle you're seeing right here, okay, and now the graph is above the x-axis, okay, so f, the area is positive, and so f will be increasing. At 2, it does hit the x-axis, right, but it bounces and goes it's still above the x-axis then, right, so area is still going to be positive there, and so then f will be increasing. So in what intervals is f increasing? From -2 to 2 union 2 to 4. Okay, because we're only observing this graph from -5 to 4. Okay. This notation here just says, right, f prime of x, right, positive sloped tangent lines. Okay, that's where f is going to be increasing, and that was my first line, and then here's the analysis for that. Okay. For question 3, we're going to use something. Ignore the red. The red are the answers. Okay, but the candidates test. Okay, what does the candidates test tell us? Okay, it tells us that if you're looking at a closed continuous differential function, okay, in an interval, that means in that interval it has to have an absolute minimum or an absolute maximum, including its endpoints. So again, if you observe a graph, okay, in a closed interval like we're doing right here, okay, then it has to have absolute extrema, okay, whether it's, you know, somewhere in between the interval or if you include the endpoints. Okay, but again, here's where the trickiness comes in. We're not observing just the y values. F of -5 here is not what's this? -3. Okay, this is area. Okay, so at f of -5, okay, we have to calculate the area from 0 to -5. That's what that means. Okay, that's what this means. That's what the graph is. Okay, this is area. So to go from 0 to -5, there's one small catch though. Okay, this is from 0 to x. The starting point was 0. They're asking us, right, according to this, from 0 this way. But what happens if we need to go this way instead, towards the left? There's a property, okay, that helps us do that. Okay, so that's where this one, that's what this means. Okay, when I asked you to write it in. Okay, so this property here is going to help you calculate areas going towards the left of a starting point. Okay, so notice that there is a minus there now. So that means any area that's above the x-axis will be negative. Any area that's below the x-axis will be negative. Okay, this is a semicircle. The area of a circle is pi r squared. If you have half a circle, that's 1/2 pi r squared. If you have a quarter only, right, because we're going, the question says, we're finding the candidates test, so the first one was f of -5. Okay, that's this one right here. You're going from 0 to -5. So that's a quarter of a circle, so 1/4 pi r squared. And then this triangle that's right here. Okay, but don't forget the minus. So then the area of this quarter circle will be negative. Of this triangle here will be positive. Okay? And when you do that, have the areas right here. Notice that the area to sorry, the area, the radius is 2. So when I plug in 2 here, 2 squared, that's 4. 4 over 4 cancels out, so you're left with just pi. So the area of a quarter circle is just pi here, okay? But remember, pi is negative, okay, because we're going towards the left. And then the area of this triangle here, base 3, height 3, times 1/2, 9 over 2. Okay, so that's this one here. F of negative 2 is the area from 0 to negative 2. That's just this quarter of the circle, right? And we found that to be negative pi. And then F of 2, that's the area from 0 to 2. That's this quarter circle here. We know that would be positive pi then. Okay, and then the area for F4, that would be from 0 to 4. That's pi plus the area of this triangle. Whoops, the area of this triangle here. Okay, base 2, height 3, times 1/2. You're going to get 3. So then, out of all of these here, okay, 9 over 2 minus pi and negative pi, which one is smaller? This one, the second one, is smaller. It's a smaller value, okay? So absolute minimum there. F of 2 is pi, F of 4 is pi over 3. Clearly, pi over 3 is bigger than pi. So that's the absolute maximum. Okay? So that's how you do the candidates test. Negative 5, negative 2, 2, and 4. Okay? That's the endpoint, the left endpoint, the right endpoint, and the 2 critical values. Okay? I think I missed that when I started this problem. Okay? But these values here, the left endpoint, right endpoint, and any critical values. Okay? That's what the candidates test tells you. Okay? And yeah, that wraps up Form A. I think from there on, all the other forms serve as good practice. Okay? I will be posting the suggested practice problems, the homework sheets for this Unit 2. There's plenty of practice there too. Alright guys, I will see you Monday.